Hello everyone, today I'm going to show you how to create a C# script for the board manager. Okay, so let's start it. Okay, so previously we were talking about how to create like a prefabs and other like different animations. So today we are going to I'm going to show you how to create a board. Okay, so basically I learned from Unity tutorial website, and I watched the tutorials for at least 5 to 10 times, and I can understand 80% of the whole script. So if you don't really understand the script that I talk today, then you can go to Unity's website and go to the tutorial and watch the rock-like 2D game tutorial, and I think that would help a lot. Okay, so bear out with me. Then I will start explain what I've learned from that tutorial. Okay, so basically we are going to create a 9x9 board. So later on I will explain why we kind of like create like a different numbers and why we have like a different render positions. Yeah, so this episode will be really hard because for me, I believe I only understand 80%. So hopefully I can teach or tell you the whole 80% that I know. Yeah, okay, so first we need to go to the script, create a folder, and create board manager and game manager. Yeah, okay, so this episode we are focusing on the board manager. Okay, so first we are using the Unity engine, and we are using the system, and then we need to type using system collections.genetic, so it will allow us to use the list. Then we need to use random because later on we are going to use vector3 random position, and we have random.range. So we need to have the class. So we need to use random equals Unity engine.random. Tells random to use Unity engine render number generator. Yeah. Okay. So we can start from here because this I believe is the code that in Unity tutorial project they have complete script and incomplete script, and I copy and paste the complete one. Yeah, and trying to figure out what's going on. Okay, so this is the understanding that I know. Okay, so basically since we named the script code board manager, so the public class for this whole script will be named board manager. Yeah. Okay, and of course we use modern behavior. Then why we need to use serializable? Because if we create a variable on the public level like loads, then because we have a lot of arrays, right? We are going to put all the arrays we did in our sprites in to make the board. Then we need to use serializable to kind of because the organization will look better on the front end. So that's why we use this. Then we have a class called count. Why we have this? Because if we set this, then we can start setting this. We can call the class count. Then we can pass the number here. Okay, so let's create a public class called count. Okay, so why we are going to have this? Because we are going to have different levels. For example, like if the level is easier, then we can have like a random number, like for example, like a 4 food at the first level and 3 food at the next level, right? So our food, our wall, our difficulties can have, or like we can have like sometimes 2, sometimes 3, sometimes 5, sometimes 2, like so we need to randomize the number of our food and our wall and our other different stuff. So make sure not every level has the same food, not every level has the same wall inside the game. So that's why we need to have minimum and maximum. Okay, so this is from what I understand. Okay, so we need to make a class. Okay, so when we make a class, we have the name called count, right? Class is always, we need to capitalize the word, like count, C capitalize. And then public count, int minimum, int maximum. What does it mean? Okay, so first, minimum and maximum means like the number, like how many do you want? For example, like because like in here, we pass out the class. For example, like a food count. Oh, the minimum we can pass to 1. The maximum we can pass to 5, right? So at least we have 1 to 5 this range of food for different levels. So this is the class that we are going to kind of show the limitation, the minimum to maximum, like what's the range for our random number for each different variables. Okay, so this is the class. So we pass minimum to the mean, we pass the maximum to the max. Okay, so let's create some public integer, public variables. Okay, so how many columns do we want? 8. Do you remember that I just said that this game is 9 by 9? Why it's 8? Because this is our game board. And 9 by 9, the extra 1 layer will be our outer board, like outer wall. So now we are talking about the wall, kind of like the fixed size. But later on, we are going to create another like outer wall, like the rock. Make sure the player and enemy is not going outside. So that's why we create 8 by 8. All the randomized, all the smile will be inside that. Then we will create like another layer totally outside of the game to make sure no one can go outside of the game board. Yeah, so that's why the whole game size will be kind of 9 units by 9 units. But as for our game, columns and rows we can set to 8. So this is our actual game board that we are going to spawn everything inside it. Okay, so it's 8 by 8. Okay, so public count, wall count. So we are going to pass 5 to 9 to randomize in each different layers. Then we are going to pass minimum 1 and maximum 5 in different levels for our food. Then exit. Okay, so then we are going to do like public game object exit. Why we are going to do that? Because if we set up this, then in the front end, Unity will you can drag that specific prefab for exit, drag into the slot for exit. Then it's easier for us to manage it. Okay, so we only have one exit, but we had a lot of floor tiles, wall tiles, food tiles, enemy tiles, outer wall tiles. So we have this bracket. The brackets means that it's serializable. We are going to kind of organize all the tiles, so we need this. Make sure, yeah, okay. Okay, so we are going to have two private variables. The first one is called transform. Transform a variable to store a reference to the transfer of our game or of our board object. So it means that we are going to have a board holder to hold all the transformation. So this is transform. Transform means that, okay, so it's our position. Okay, for example, like transform position. Yeah, so basically we are going to hold like a parent, we are going to hold all our children, all the tiles, randomized tiles, spawning in different positions. So this is our parent. We are going to pass an object which is an empty object. Okay, and then private list vector 3, grid position new list vector 3. What's this? Okay, this is a list of possible locations to place tiles. Okay, grid positions. Okay, so board holder means a variable stores a reference to transfer our board project. So this is the mother. And then grid position is kind of like this is a list, like grid position, like for example, like minus one, minus 1, 0, minus 1, 1, like those XY. This will be a list of children. So the first one, private transform board holder, will be the parent, and private list vector grid positions will be the list of children position, child positions, to represent different randomized tiles. Okay, so yeah. Okay, so that started by initialize the list. Okay, so first we are going to clear the whole grid. Yeah, like you need to make the default to kind of stop or clear everything before you spawn it. So we need to clear everything first. And second, we start looping. Okay, so this one is a little, yeah, we need to start thinking about it. Okay, so why we use 1 and column minus 1? Okay, so basically we have A by A board, right? Okay, imagine we have A by A board, and then so the original position will be 0 by 0, right? So if we set XY by 1, what does it mean? It means that 0 by 0, 0, 0, and 1, 1, there's a square, empty square, or like a line between it. So make sure our player, because sometimes when we spawn the enemy, the wall, the food, sometimes if we don't create a clear path outside of the spawning battle area, then sometimes the player, for example, like if the player just start from the place and we spawn like 3 walls just around the player, then the player just couldn't get out, right? So we are creating a safe path outside the randomized board in order for the game to go smoothly. So that's why we started from 1, 1, x equals 1, y equals 1. So make sure we have a clear path outside of the board. Okay, so this. Okay, so maybe I can start drawing something, so you can Understand? Yeah, so basically we are leaving a path. Okay, so let's do it. Yeah, because let me create new. Okay, so the whole game board. Okay, let me show you the whole game board. Maybe this. Okay, so this is the whole game board. This is the whole game board, right? Okay, so we set up A by A. Okay, so this is 0. U. Okay, so this is the inner one. So this is right. So 0, 0, A by A, and then we are going to create outer board. Okay, wow, I think my drawing is not that bad. Okay, cool. Okay, so and the outer board is -1, -1, and this will be sorry. So this will be AA, and this 0, 0, AA, and this is -1, -1. Okay, so this is the game board. This is the board that we are going to spawn all the like more like gameplay. Like, okay, so those will be the enemy and the food and wall spawn. So okay, so you see, like we put 1, -1. What does it mean? So this means that this is okay, I'm sorry. So this is 0, 0. So this is AA, and this is 0, 0. This is AA. Okay, so this is 1, 1. So start with 1, 1, and then okay, so and then columns is 7, right? Columns is 8. 8 minus 1 equals 7, but it's like a less than 7, so it's 6. Okay, so and this is 6. Sorry. Okay, so this is the whole board. So make sure we have a clear path for our okay, so we can have a clear path here. Okay, so basically we are going to do the grid position. Initial setup will be this one. Will be inside this one, right? So we are going to do this one, the red one, Okay, so let me take out this so you won't mess up. Okay, so this one will be 1 and x less than 7, which means x equals 6. So this will be here and there. So this is the limitation for the x and y. Okay, so at each we add a new vector 3 to our list with x and y coordinates of the position. So inside here we are going to add a new vector x, y, and 0, f. Means that there's no z position because this is a 2D game. So what this will do is that, okay, we are going to make a initialized list from 1, 1 to 6, 6, and the computer will start listing out like a 1, 1, 1, 2, 1, 3, to 6, 6. Okay, so this is called the initialize the grid position dot add. Okay, so this will be the initialize list function in which start to do the grid position. Yeah. Okay, so this is the grid position under the initialize list. Okay, so what's board setup? Okay, so set up outer walls and floor background of the game board. Okay, so we've already set up the red one, right? Then this board setup will be, let's do the green one. Okay, so this will be the path, right? This is the floor. Floor will be 0, 0 to 7, right? Like somewhere 7. Yeah, somewhere 7. And I need to draw another outer wall. So the outer wall. Shit. Okay. Okay, bear with me. I use my mouse to draw it. Okay, so outer wall. Okay, so floor, the green one will be, okay, bear out with me, so chaotic. So will be 0, 0 to 7, 7, 7. Yeah, so this will be I would say more like the floor, right? This will be the floor. And then the green one and the black outer wall will be minus, minus 1. Wow. Okay, so the black one will be the outer. So we are going to do the black one and the green one on the board setup. Okay. Wow. Okay, so first, board holder is a new object board that transforms. What does it mean? Okay, so this means that board holder will be the game object code board that transform. Okay, so game object board, we go here and we are going to have a game object and we are going to make it like a start to initialize board and set board holder to its transform. Okay, so let's do it. Then we start to loop around the x-axis. Start from -1 to fill the corner. Okay, so -1 code. Okay, so this means that we start with -1. Yeah, right. -1. Oh, need to use another color. Too ugly. Okay, so let's use purple. Okay, so what does it mean? It means that integer is x equals -1. Okay, so this one, and then colon +1. Okay, so colon is 8, right? Because previously we set the number 8. So, which means that 8 plus 1 equals 9. But x is less than 9. Means that x only can be 8, right? So this is a tricky part. Okay, so the outer wall border will be -1 to 8 by 8. Okay. Okay, so yeah, so we start creating it and same as the Y position. Yeah. Okay, so we start to initiate. Well, what's this? Okay, so we start to trying to put spawn, choose random tile from our array of the floor, prefab and prepare to initiate. So basically, we are going to put all the floor, like we are going to mapping the whole thing with floor. The floor, let's say it's green. So this one is the giant size. It's a green size. Oh, I don't know whether this makes sense or not. Okay, let's do the layers. Okay, let's do this. Okay, so this code, game object to initiate floor tiles random floor tiles length. It means that I am going to choose the whole list from my floor tiles to map out the whole thing. Okay, so this super giant green section will be this code. And then if, because we are looping, right? We are nesting and we are looping. And then if the current position is just at the board edge, then we start to put random outer wall prefab from our array outer tiles. Okay, so we are trying to do this, right? But we are going to create outer wall. So by creating this, if the x equals -1, x equals -1, y equals -1, x equals columns. What does it mean? Because our range is columns plus 1 equals 9, but it's less, so column will be 8. If x happens to be 8 and y happens to be 8, so it means like, oh, you are at the super edge of the outer wall, then we are going to instantiate the outer wall, like a random range, from 0 to the whole length, like the minimum to the maximum, but it's the number of it. Okay, then we instantiate the game object instead of using the prefab chosen to instantiate at vector 3. Okay, so this means that we are going to instantiate this to instantiate thing, right? So we are going to instantiate. This means okay, so let's see. So this is the game object. To instantiate is the game object we get from the floor tiles to outer wall tiles. This is the object. And then we are going to pass the position. Then we are going to do the quaternion, means the rotation. Since we are not going to rotate any tiles, we can do quaternion the identity, means that there's no rotation on this instantiate. Yeah, okay. So set the parent of our newly instantiated object instead to board holder. This is just organizational to avoid cluttering hierarchy. Okay, so instantiate the transfer the set parent. So we want to make sure it's under the board holder. So we set this as the like board holder as the parent of the whole instantiate. Yeah, instantiate stuff. Okay. Then we need to randomize all the position of the grid position, because we don't want like a few, they are kind of like not randomly, they are like, okay, if we don't randomize our board, then every level will look the same, and maybe all the food will be super far away, or all the enemy will just like surrounded you, and when you just first on land you just die. Yeah, so we want to randomize the position. Okay, so we do random index random.range Okay, so we want to make sure that the value is from the 0 to the grid position that count. Yeah, this part is a little hard. I'm trying to understand now. Okay, so vector 3 random position equals grid position random that index. Okay, so we are trying to randomize the grid position. So you can take a look, and we need to remove the spawn random spawn position. Remove it before you spawn it again. So you kind of like do it, and then you remove it, and then you return it. I know it's really weird. Yeah, why you spawn? You work so hard to create a code to spawn stuff, and then you remove it. Okay, I don't get it, but it seems like everything works. So we just, maybe in the future when we start learn more and we will get more. Yeah, okay. So that's what I'm thinking. Okay, so void layout object at random. Okay, so what does it mean? So this means that accept the array of game object chosen by minimum maximum range. Okay, so we are going to create this part, the red part. Okay, this part, the red part. Okay, this is the red part. Okay, so this red part, it means that for this. Yeah. So this part, we are going to make sure like all the instantiate objects is in its random array. Okay. So those two, it's like we spawn a random position and we lay out those random position into an array. Okay, so it seems like that. So if you can take a look, you will understand more. Yeah, I just pause so you can take a look. I know it's a really, really abstract idea. Okay, so so this is just position individually. This is the array. We are going to have like different arrays, kind of like take the previous random position into like a higher level of array, and we add like minimum and maximum numbers of those randomized array. Yeah. Okay. Okay. So set up scenes. Yeah, this part I understand more. The randomized part, I think, we can kind of like browsing it. If we don't really understand it, that's fine. As long as we keep learning, we won't understand in the future. Yeah, okay. So the setup scene initialized our level and calls the previous functions to lay out the game board. Okay, so public void setup scene in level. Okay, so we need to create a board setup, and then we need to reset our initialized list that we just created before. Then we need to initialize a random number of wall tiles based on minimum and maximum and randomized position. So we need to lay our object at random. Wall tiles, wall count at minimum, wall count at maximum. Yeah, so we start laying out according to the minimum and maximum that we set before. Okay, then we need to laying out randomly about the food. But as for enemy, we want to increase the difficulties while playing the game. So we do like int enemy count, int math.f log level 2. So on this code, it means that this code, it means that every level we are kind of like a times 2. For example, like the first one we got 2 enemy. Second level we are going to have 4 enemy. So make sure everything is like the difficulty is like getting harder and harder. Then okay, so then we instantiate a random number of enemies based on minimal and maximal and randomized position. Okay, so lay out object at random, enemy tiles, enemy car, enemy car. Okay, instantiate exit new vector columns -1, row -1, 0. Okay, so it means that we start instantiate and we start have the make sure it start like a starts from column -1, row -1. So exit tile. Okay, oh sorry. So exit will always be 7. So this is sorry. So the green one, we are going to have this one. It's called 7. Shit. It's green one, 7. 7 is the fixed position of the exit. Yeah, because the exit will always be the upper right corner, but be inside the outer wall. Outer wall is 8 by 8, right? Okay, cool. Okay, so finally we finished the board code, and next episode we are going to talk about the game manager. Okay, so those are the hard one. We need to conquer the hardness of the C# in order to get the lovely fruit of our game. Okay, so we need to get through the hell, and when we are in hell we need to keep going. Yeah, okay, so next one is another hard one. Okay, so thanks for watching, and see you next time. Bye bye.